we are going to do motion word problems. Again, we keep adding more complexity to it. Basically, at this point in time, all the word problems that you've been given with motion relating to distance, rate times time equals distance, have involved two people. Am I right? Or two cars, or two vehicles, or two something, right? One was going 60 miles an hour, the other was going 80 miles an hour. They were going away from each other because they didn't like each other, right? How long did it take before they were this many miles apart? Or they were in two different cities moving towards each other, right? Two people, two vehicles. But some word problems with motion involve just one person. But it involves going one way. Well, sometimes. There's different options. But what we're going to talk about today is this one person starts here, goes this way at a certain speed, turns around, and goes back at a different speed, right? And then they tell you the total amount of time it took to go from here back to here again. Does that make sense? Okay, so, and there's just one little trick you need to know in order to do this.
Wait, Gary, would this be like someone's like swimming 50, and it's they take like a minute to get down there, and how many seconds you think going down there?
Kind of, yeah, it'd be similar to that. It'd be similar to that. So I could definitely write a problem like that. But okay, so this is the type 4 kind of problems that I'm going to talk. So let's read it first. A cyclist rode to the beach. Scott, why don't you have a seat right here? So a cycler rode to the beach, okay? Rode to the beach at 24 miles per hour. Boom. Turned around because he forgot his orange juice. And he came back again, but he was a little tired, more tired, so he came 20 miles per hour. He only went 20 miles per hour. The total trip took him 11 hours. That's why he needed his orange juice, because he was traveling for 11 hours. That's a lot of time. I just realized this is a weird problem, isn't it? 11 hours. Jeez. Okay. Anyways, I just took it off of a sheet, so I didn't.
Only Matthew had 11 hours and not
Okay.
so far away.
So let's, again, the box method helps. It really helps to organize information. So let's create the box. All right, so we got rate times time equals distance. And we know he's going to the beach. Well, we'll just say to beach for the first one, and back, right? Back home, whatever. Back, yeah, we'll say back home. Back home.
Back home.
Okay?
He must really like swimming.
All right, so what can I do? What can I put in the box?
Well, you know the rate.
Okay, so what can I put in the box?
So 24 on the beach, you can put 24 under.
Right here, onto the beach, he went 24 miles per hour here, okay.
And then on the bottom is 20.
And then this one, back home, he went 20 miles per hour.
And then the time is 11 hours for both. For
So
both.
you
Total time.
Yeah, you put a little box below. What do you call it? X plus 11 for number 1, and the second is X, correct?
Okay, so that's interesting. Some people, at first we were thinking, oh, well, we just put 11 for both. But wait a minute, it doesn't mean he went 11 hours going to the beach and then another 11 hours going back home.
22 hours.
It wasn't 22 hours. It was a total trip of 11 hours, right? So, Issa, what were you saying?
You put a little box under.
Yeah.
Put a what?
Like you know, like for the.
Oh, I see. Put a little box under here.
Yeah, and then put 11.
That would work. Right?
It would work. You just write and then, but you don't know the distance either.
That's an interesting thought. I never thought of that before. So I'm just going to play with it for a second.
Oh, yeah, it makes sense. And then like you can do it.
And so you're saying this is 11. So we know, if I'm hearing you right, we know that this plus this equals 11. Am I right? But we don't know what this is, and we don't know what this is. Do you agree with me?
Then figure it out, Gary.
So could we start with X and Y since we
Yeah.
don't know either one? Let's just try that for a second. Now the problem is I really don't want two variables.
So you only want one.
I only want one type of variable. But for now, I've got an x and y, just for a second. Guys, just give me a second. So, could I write an equation just for a second relating to the x and y and 11? What could I?
You could say,
Twenty-four
y
x
equals,
equals.
wait,
Well,
wait.
how about, isn't it this plus this equals this? Isn't that what we're saying?
Yeah,
So,
if you-
Right?
24
Because the total trip was 11 hours. We know x plus y equals, so we know x plus y. You guys agree with me this?
You could say x,
You guys agree with me?
yeah,
X plus y equals 11. Is everybody on the same page?
yeah.
Okay.
You could subtract y from both sides. I don't know
What if
about-
we subtracted x from both sides? What if we solved for y? Is that okay?
Do it.
All right, let's do it. So what would I do? Subtract x from both sides. Subtract x from both sides. I have y is equal to what?
11, a negative 11.
Okay, 11 minus x. That's
Yeah,
fine.
Whatever it is.
11 minus x. Now, what could I do?
I
I
don't,
could put in the box that would get rid of my y.
oh,
Bella, what do you think?
you gotta replace the y with 11 minus x.
Oh my god, y is exactly the same thing as 11 minus x. That's amazing. So instead of y, I don't need y over here. I could just put 11 minus x. Do you guys see that? Does that make sense?
Oh my god, Gary.
Where did I lose you? Yeah, well, did it make sense to you? Oh, it makes, I thought you were going,
You're a wizard, Carrie.
you know.
Here we are with us.
Okay, so that's awesome. So first we had x plus y is equal to 11. This is so cool. I've never taught it like this before. Brilliant, my dear. Yes.
So you wouldn't have to do that whole like x plus y equals 11. You could just put 11 minus x.
Yeah, so this actually is a majorly important trick. You will use this in Algebra 2. You will use this in pre-calculus. You will use this in calculus. When somebody says the sum of two numbers add up to 20, and you don't know what they are, one of them is x, and the other is whatever we have left over when you subtract the x from the total. Does that make sense?
No.
I know, it's confusing.
No, I mean, how would you write that out? I know what the logic is, but I don't know.
Okay, so let me show you the logic. This is really kind of a cool way to do it. In a way, this is easier than what I'm about to show you. But if you, can I just erase this now?
Yeah.
All right, so let's say I had a little thing and I said, the sum of two numbers equals 10, all right? And if, let's say my first number is, let's do like this. Let's say my first number is 2. What is my second number?
8.
8. Everybody gets that? How did you get that? Who said 8?
Because you subtract 10 from 2
Okay,
from 10.
so you do 10, the total, am I right? You start with the total, you take the 2 away from it, and then you get an 8, am I right? That's what's left over when you take this away from the total, yes? So let's say it was 7, the first
3.
number. It's 3, how'd you get it?
Subtract
10
7.
minus 7, right? You start with the total
You know this by now.
minus the 7, right? No, this is really difficult math.
No, I mean like
This
10
is-
minus 7 equals 3.
Did you just do that in your head?
Whoa!
I'm impressed.
Oh my god, we tired for you.
Oh my gosh.
Worship her.
Okay.
Nobody's
All right. So if this is 4, what is this?
6.
6, which is the total minus 4, right?
Oh, so
All right.
it was x.
So what if this was x?
It's 10 minus x.
It's going to be the total minus x, right? That's how I figured out, but since they're not like terms, I can't go any further, so I'll just put 10 minus x right here. So when two numbers add up to a number, one of them is x and the other one is the total minus the x. It's not x minus the total, it's the total minus the x, right? You see that? And so that's how that works. And that's an amazing trick. It's an amazing trick, and it makes these really easy. So what would oh, we did it. So we've got this and this, right? So 24 times x is 20. So d, if you guys all remember, all you have to do to find d is you just do what it says. Rate times time. 24 times x is 24x. 20 times 11 minus x is, I'm gonna just do it with a parenthesis. 20 parenthesis 11 minus x.
You could also just.
So that way you use distributive property
Yeah.
Correct, correct.
when you're doing
It
the
could also
problem
be
itself.
Correct.
it could also be 120 and negative 11.
Correct. So,
Yeah. No,
So-
negative 11. Sorry, not negative 11. Shh, don't listen.
Minus
alright,
x.
well, I'll get there in a second, so,
So could you also do like, could you
Okay.
also just flip it around, like have 24? be
okay, wait,
11
guys,
x,
there's
and
talking,
then
let's stop. Go ahead.
Could you have like 11x on the top and then x on the bottom?
Oh,
Or
wow,
does
what do
it
you think?
matter?
Could I have put 11 minus x on the top and just x here?
No.
Yeah.
Well, maybe.
Yeah, yeah, it makes no difference, because let's say x was, let's say we figured this out the way it is. Let's say we figured this out the way it is, and we said x was, we found out that x was 2. This would be 9, right? Okay, but let's say we did it the other way around. We found that we would not get x is 2, we would get x is 9, and 11 minus 9 is 2. See what I'm saying?
Yes.
X would just be the other thing.
But then you started off with x and y, then wouldn't you have to have like y on the bottom and then 11 minus y on the top? Because you
Well-
started out with having x and y.
But that was because I wanted to show you that x plus y, if that equals 11, I could solve for y by subtracting x. X is equal to 11 minus x. And I could replace the y, right?
Okay, so it
So
doesn't
I could have put,
matter.
I could have put y here and x here, right? Make sense?
So it doesn't really matter which variable.
No, doesn't matter, yeah. I like x's better, so I solve for y so that I'm not dealing with x's. But it's totally fine to use z's or w's or anything you want. Okay, so now what do we do? So we filled in our box, right? We filled in our box, what do we do with this information? Make the equation.
Problem, like
We
24
solved.
minus whatever 20
So
is
do I say this plus this equals some unknown?
No, wait, no, because don't they equal the same thing because they're going there and then they're coming back?
Wait a minute. You're trying to tell me that if somebody starts at point A and they go to point B, that distance is the same as starting at point B and going to point A?
If they take the same route, it is.
God, you guys are too smart. Okay, so that's right. So this equals this, right? Everybody understands that, right? Totally the same distance, right? That's often the case when you have one person problems, right? They're going this way at one speed, they're going back at the other speed. So this distance equals this distance, right? All right, so we're gonna do that. 24x is equal to 20 parentheses 11 minus x. Okay, so let's get rid of our parentheses. 24x is equal to
It's 120, or 220, sorry.
220.
Equals 2.
All right, you're right on that for sure? 20,
Minus-
yeah, that's right.
yeah.
Okay, minus 20x, am I right?
So now we got a plus to 20x.
You what? Say it again?
Plus 20x.
Okay, so we have our x's on both sides, right? That's the problem. We gotta get them all on the same
Add
side.
20x to both sides.
So we're gonna add 20x to both sides.
Oh my gosh, it's 44x.
Add 20x. It's 44x. Whatever that means.
What's 44x? What's 44x?
Okay, so right, I gotta divide.
You like fours.
Okay, so I've gotta divide by 44. Everybody's with me?
Yep.
Yep. 5.
Right?
X equals number 5.
Yep, x equals 5.
calculator.
What? I did it in my
right now.
So x is equal to 5. So what's my answer?
Oh,
Yeah, 5 hours in each direction.
No, because it's 5, x equals
Well,
5,
what
so to the beach it took 5 hours, and then back from the beach it took 6 hours because it's 11 minus 5.
So
Oh,
look,
okay,
look at the question. It says how much time was spent in each direction. What did we solve for? X is, we have to find x in our box.
X is
Oh,
two.
x is time. So we know to going to the beach, he went exactly
5 and a
5
half.
hours.
5, yeah.
5 hours. X
Five
is
and
5,
six.
right?
And
then
then
11
11
minus
minus
5
is 6.
11 minus 5 is 6. So
hours here
going back home at a slower rate, he actually traveled 6 miles, for 6 hours, right? Makes sense?
Are we good? Can we start homework?
And then he got his orange juice, and then he went back to the beach.
Because he was fully recovered, so then it only took him 2 hours to get back to the beach.
This is a long time, buddy. By the time we got there, it was already the next day.
All right, so I think what I want to do is I'm going to pass that. Just listen to me for a second, because we're not going to do the homework for the whole rest of the period. We're actually going to play a game. But
24?
I want to. What I'm going to do is I'm going to pass out the homework.
Did you turn off the camera?
Oh yeah, thank you.